Hey, welcome back, kiddos. Now we're going to talk about Unit 9.7, which is about angles of elevation and depression. So I know you've heard those words before, but let's put it in the context of math. So our ancestral question is today: what are the angles of elevation and depression, and how are they drawn in a right triangle? So especially we're going to talk about how we can draw a representation of that, and what are those. All right, so let's just get right into it. Okay, so first off, let's talk about up, right? If we go up, that's going to be called an angle of elevation. Okay, because you can think if you elevate something, that means you go up, right? So it's the upwards angle from the horizontal to a line of sight from the observer to some point of interest. So what that means is horizontal, right? We look at the horizon, right? If we look straight ahead that way, whatever we look up is called that angle of elevation. Okay, so that's what that is right there. Okay, and then similar, if we look down, that's going to be called the angle of depression. Okay, so that's what this is right over here. Okay, so if we're looking straight ahead and then we look down at that dog, that's going to be called the angle of depression. Okay, so that's what we're talking about today: angle of elevation and an angle of depression. So let's just break it down a little bit better, even. Angles of depression, right? So if we're looking straight ahead, if we're looking at a tree, we don't start at our foot, okay? So it's not there, okay? It's right there at our eyesight. Okay, so that's the main thing because it's from your line of sight. Okay, so if we start from a line of sight and say I'm going to the top of there, that's called the angle of elevation. Okay, so when we're looking up, that's called the angle of elevation. Okay, so then similarly, if we're looking down, that's going to be the angle of depression. So if we're looking from right here, so we would be thinking right here, right? If that's us, we're looking from our eyesight, oh, not from where we're sitting, we're standing. Okay, it's where our eyesight is, so it's always from the light of sight. So that's called the angle of depression. Now, common mistake is for us to think of it's right there. Okay, it's not right here. It's from this horizontal line. Okay, so we have to think about that. All right, so that's the basics of what we're talking about today, so we don't mess that up. And I have a special thing for us to do that. Okay, so let's think about that as well. So if we said that a line of down is depression, okay, and going up is elevation. So since horizontal lines are parallel, now we're bringing in what we talked about from horizontal and alternate interior angles. So the angle of elevation and angle of depression are congruent. Okay, that means they have the same measure. Okay, so whatever this is, right? Say I'm at this, um, I'm right over here, and I'm looking up. I'm looking up towards there. That would be called the angle of elevation, right? And if I'm from here and I'm looking down, that would be called the angle of depression. Okay, but they are both the same. So whatever this is going to be equal to that. Okay, so that's what we want to keep in mind. The angle of depression and the angle of elevation are congruent. Okay, so that's a key thing. They are congruent. And we're going to keep that in mind as we're practicing this. So let's take a look over here. All right, so let's identify the angle of elevation and the angle of, this is supposed to be depression. Okay, so we're going to say angle of elevation is AOE, and then angle of depression is AOD. All right, so let's do this. So the angle of elevation and the angle of depression. All right, so think about this and pause the video. See if you can label the angle of elevation. All right, so if we're looking right here, the angle of elevation would be right there. So that would be from LST. So angle LST. All right, thinking about that, what would be angle of depression? Okay, so if we're right over here, if we're looking down, we start from this horizontal, right? So if we're looking down, this would be that's going to be the angle of elevation, right? And this is the angle of depression. We're going to call that FLS. Angle FLS. So what does that tell us? That says, let's write this out. The measurement of angle LST, right, is congruent with the measurement of angle FLT. Okay, so those are congruent. That's what we want to take from that. Okay, angle of elevation, angle of depression are the same. All right, so thinking about this one. All right, go ahead and do this. AOE and AOD. Tell me angle of elevation, angle of depression. All right, elevation would be right here, right? TWS. Angle TWS. All right, depression would be right here. If I'm up here on the Ferris wheel, I'm looking down at this person. That would be RTW. Okay, angle RTW. And we know that they are congruent. So angle TWS, or the measurement, right? TWS, measurement of angle TWS is equal to the measurement of angle RTW. All right, so let's keep that in mind. Let's go ahead and get right into some examples. All right, so it says using this to solve real world problems. So real world, we're going to draw a picture. It says you're measuring the height of a spruce tree. All right, that's what we're trying to find. So that is what is x. So let's look over here. Height would be up and down, right? So that's going to be x right there. That's what we're trying to find. And you stand 45 feet from the base. Okay, so if that's the tree, if that's the base, that means this is 45 feet. So if you're standing right over here, okay, okay, that's at 45 feet. It says you measure the angle of elevation to the ground, from the ground to the top of the tree to be 59. So we know that's the angle of elevation right there. Find the height of the tree. Okay, so from this perspective, let's go ahead and label those sides, right? We're going to say that this is the, let's just change a different color. That's going to be the opposite. That's a hypotenuse, right? Opposite and then adjacent. So what are we working with? We're working with the opposite side and the adjacent. So we're going to think TOA, right? Opposite over adjacent. So the tangent of 59 degrees is equal to the ratio of opposite over adjacent. So x over 45. Okay, so now we're just going to cross multiply. Okay. Okay, so 1 times x is just going to give us x equals 45 times tangent of 59 is going to be written as 45 tangent 59. Okay, so now all we're going to do is just type that into our calculator and go from there.